All right, now let's take a look at a solenoid and an electromagnet. So in this video, first let's start with the solenoid. We know a solenoid is a coil of wire that produces a magnetic field when carrying an electric current. So what that means, in order for you to build one, we will need a coil of wire. So in our lab, what it looks like is it has this insulated blue material on the outside, and then you'll see that there's a metal wire that runs through it, a metal material of some sort. So you're going to need the wire to build your solenoid, and you're also going to need an electric current, and that's going to be provided by one of your batteries. And again, I'm going to use this larger 6-volt battery. That way we get a stronger current, a higher magnitude of current flowing through this wire. So to build a solenoid, you want to take the wire, and what I do is I usually just wrap it around my fingers. So use your fingers to make a coil the best you can. And this is how you would demonstrate to your teacher when they ask you to build a solenoid. What does a solenoid look like? It is a coil of wire with a current running through it. So we're going to allow a current to run through it by touching the ends of the wire to the terminals of your battery. Let's move that to the center there. Okay, and place one end of the wire on one terminal and the other end on the other. Now you do want to be careful when you do that, since you're running a current through this wire. It is going to start to get warm. If it does get too warm, just disconnect it. So I encourage my students not to hook it on there and walk away, just because it's going to get too hot. You don't want to do that. You don't want to melt the insulative material on the outside of the wire or anything like that. All right, so that's your solenoid. That's it. It's a coil of wire with a current, an electric current running through it provided by the battery. And what this does, just by simply doing that, you're creating a magnetic field on the outside of this coil. Now the magnetic field isn't very strong in a solenoid, so if your teacher has a compass, you could actually bring a compass near it and watch the needle move about, just to prove and to show you that there is a magnetic field being produced around the outside of this solenoid. So to take this solenoid and turn it into an electromagnet, it's pretty simple. An electromagnet is a magnet that consists of a solenoid wrapped around an iron core. So you want to take this solenoid, and the only thing you need to turn it into an electromagnet would be an iron core. So we typically use in lab a nail. The nail that you have in your lab station is a little bit bigger, so you're going to have a larger iron core, so it's going to work even better than the one that I'm using here. So I'm going to stretch out my wire, and I'm going to take that wire and I'm going to wrap it around my nail or my iron core. Sorry, it's a little bit hard to see there, but I'm going to wrap that coil around my nail. The closer you get those coils together and the more coils you can have on your electromagnet, the better and the stronger the magnetic field you're going to produce. Okay, so I want to show you what this does, and then we'll talk about the ways in which you can increase the strength of this magnet that you're creating by building this electromagnet. So when your teacher asks you to build an electromagnet, these are the materials that you're going to need. You're going to need this coil of wire, you're going to need the battery, and you're going to need the iron core. Really similar to that solenoid, you just added the iron core. Okay, let's see if I can get this all in the picture here. But what you're going to do, you're going to hook the wire up to your power source, allowing a current to run through the electromagnet. And the reason that I have staples here is to show you that the strength of the magnetic field is even stronger from your solenoid to your electromagnet. This electromagnet with a 6-volt battery is strong enough that you should be able to pick up some staples. Look at that. So that is definitely producing a magnetic field by allowing that current to run through this coil of wire with the iron core. That was a pretty strong electromagnet. So the ways that I can make that even stronger, there's 3 ways that you can increase the strength of the magnetic field on an electromagnet. Number 1, you want to increase the number of loops in the coil. So the closer, like I said, the closer you have these coils pushed together and the more coils you can get around that iron core, the stronger that electromagnet's going to be. So increase the number of loops. The second one would be to increase the current. So the current being from the battery. So using a larger battery in essence would increase the current and give you a stronger magnetic field on your electromagnet. And then the third way, you could increase the size of the iron core. So that being just a larger nail. So try out the larger nail that you have at your station and see how many staples you can pick up. So one way to memorize the 3 ways that you can increase the magnetic strength of your electromagnet, I like to think of it as the 3 C's. So increase the number of loops in the coil. So coil, current, increase the size of the current from the battery, and core, increase the size of the core, the iron core, the metal core in your electromagnet. So coil, current, and core. And that's how you're going to make a stronger electromagnet. So give it a try. Try out a smaller battery, try out a bigger nail, try less loops, kind of play around with the combinations and see if you can pick up more staples than your friends at the station.